Good day. This is a Professor, CBMD PhD, and today's Saturday, March 21st, 2026. It is 12:24 and 58 seconds, p.m. Eastern Standard Time, and today's research, light and atoms. So let's hop to it here. Since light waves have such high frequencies, a different mode of generation comes into play. We can no longer count on the controlled movement of free electrons outside atoms and molecules. Rather, light and all the radiations in the higher frequencies are generated by the movement of electrons inside atoms and molecules. Let us review momentarily the modern, albeit highly simplified conception of an atom. Remember that no one has yet seen one. We describe the atom on the basis of how it acts, as well as how it reacts to things scientists do to it. For the present purpose, the best model we have of the atom is that of a miniature solar system, with a nucleus or heavy part of the center, and cloud of electrons dashing around the nucleus in fixed orbits. The term fixed orbits is used advisedly. Our planet moves in a certain orbit around the sun. If we attach a large enough rocket to the Earth, we theoretically could move it closer to or farther away from the sun. In the atom, we have learned, this cannot be done. An electron can only exist in one of a certain number of fixed orbits. Different kinds of atoms have different numbers of orbits. We might think in terms of an elevator that can only stop at various floors of an apartment building. Each upper floor is like an orbit of the electron, but you get nothing for nothing in the world of physics. And just as it takes energy to raise an elevator to a higher floor, it takes energy to move an electron to an outer orbit. Hence, the atom is said to be raised to higher energy levels. When an electron is nudged to an outer orbit, the energy input can be of many different kinds. Examples are heat, pressure, electrical current, chemical energy, and various forms of electromagnetic radiation. If too much energy is put into the elevator, it goes flying out the roof. If too much energy is put into the atom, one or more of its electrons will go flying out of the atom. This is called ionization, and the atom now minus one of its negative electrons, and therefore positively charged, is called a positive ion. But if the right amount of energy is put into the atom, one of its electrons will merely be raised to a higher energy level. The higher energy levels are abnormal, or excited, states, however, and the electron will shortly fall back to its normal ground state orbit, assuming some other electron has not fallen into it first. In order for the electron to do this, go back to its normal orbit, it must give off the energy it has acquired. This it does in the form of electromagnetic radiation. The energy difference between the two levels will determine what kind of radiation is emitted, for there is a direct correlation between energy and frequency. If the energy difference between the two levels is such that the frequency of emitted radiation is roughly between 10 to the power 14 and 10 to the power 15 cycles per second, we see the radiation is light. When more energy is added, the radiation emerges as ultraviolet or X-rays. In other words, the higher the energy difference, the higher the frequency, and vice versa. Thus it is that cosmic rays with the highest frequencies known to man can pass right through us as if we weren't there. This simple picture of energy levels and associated frequencies doesn't quite hold for ordinary white light. However, such light is generally produced by a process called incandescence, which results from the heating of a material until it glows. True, the atoms of the incandescent material are being raised to higher energy levels by chemical energy, as in fire, electricity, light bulb, or nuclear energy, the sun. In a hot solid, however, the explanation becomes more complicated. Many different electronic configurations are possible, and the differences in energy among the various levels, which can be many more. Thus, while the incandescent electric bulb is a great advance over fire, it is still a very insufficient source of light. Because it depends upon incandescence, a considerable portion of the electrical input goes into the production of unwanted heat, for the bulb's filament radiates in the infrared as well as a visible region. For providing illumination, a fluorescent tube is far more efficient than the incandescent lamp. A 40-watt fluorescent tube gives as much light as a 150-watt incandescent light. This is because its radiation is more controlled, operating more in accord with our description of electronic energy levels. Hence, more of its output is in the desired visual region of the spectrum. In certain types of lighting, particular energy level changes may predominate, leading to the characteristic colors of neon tubes and vapor lamps. Although the resulting radiation bandwidth is narrow enough in these devices to appear as a definite color instead of the broad spectrum we know as white, it is still quite broad. In other words, the radiation is still frequency incoherent, and it is still spatially incoherent. To understand this, let us return for a moment to the group of radio antennas. All of them, you will recall, could be made to radiate in phase. In the production of light, however, each antenna is replaced by a single atom. This creates two problems. First, because the energy stored in the atom is quite small, it comes out not as a continuous wave but as a tiny packet of radiation, a photon. It has an effect more like the hack of an axe than the buzz of a power saw. Second, atoms are notoriously individualistic. When a batch of atoms in a material has been raised to higher energy levels, there is no way to know in what order or in what direction they will release their energy. This kind of process is called spontaneous emission. Since each atom makes up its own mind, all we know is what within a certain period of time, a short period to be sure, a certain percentage of these higher energy atoms will release their photons. And this video was created for educational purposes only. My code name is Will. I'm Professor Christopher Brunet, leader of research, scientist, ufologist, psychic, computer technician, computer programmer, philanthropist, writer, mathematician, artist, photographer, film producer, chef, animal, and nature lover. My passion is world peace. Have a great day. Good day. This is a Professor, CBMD, PhD.